Beneath the tranquil horizon, the ocean hides a truth that is as beautiful as it is brutal. From above, its surface shimmers like glass under sunlight, inviting awe and fascination. Yet beneath that deceptive calm lies a world of motion, energy, and violence that humanity only begins to comprehend. The oceans are the lifeblood of Earth, covering over 70% of the planet's surface, driving climate, feeding ecosystems, and regulating weather. But they are also arenas of extreme forces where storms surge with hundreds of kilometers per hour winds, rogue waves rise without warning, and entire ecosystems are shaped by the unrelenting power of water. In this documentary exploration, we journey into these unreal ocean frontiers, where survival depends on understanding nature's rules, respecting its fury, and harnessing scientific knowledge to navigate the seemingly impossible. The most iconic manifestations of oceanic fury are the storms that rage across open water. Cyclones, hurricanes, and typhoons are rotating systems powered by heat extracted from warm ocean surfaces. The energy in these storms is staggering. A mature hurricane releases energy equivalent to multiple nuclear explosions per second. Heat from the water evaporates into the air, condenses into clouds, and drives powerful winds and torrential rain. Storm surge, the rise in sea level caused by low pressure and wind, can inundate coastlines tens of kilometers inland. The forces involved are not abstract. They can capsize ships, erode shorelines, and reshape entire coastlines in hours. Rogue waves, another terrifying oceanic phenomenon, exemplify the unpredictability of the sea. Unlike the predictable patterns of tides and swell, rogue waves appear seemingly without warning. They can exceed 30 meters in height, towering over even large ships. For centuries, sailors spoke of walls of water that struck suddenly, often dismissed as exaggeration or myth. Modern measurements using satellite altimetry and buoy data have confirmed these waves as real, a product of complex interactions among ocean currents, wind systems, and wave interference. Rogue waves remind us that the ocean is a nonlinear system where energy can converge in a single location to produce forces far beyond expectation. The thermodynamics of the ocean underlie much of this violence. Sunlight warms surface layers, creating temperature gradients. The difference between warm surface water and cold deep water drives convection and contributes to the formation of strong currents. These currents interact with wind, topography, and tides to create turbulence, eddies, and localized zones of extreme wave height. The Gulf Stream in the Atlantic, the Kuroshio Current in the Pacific, and the Antarctic Circumpolar Current all act as highways of energy, transporting heat and momentum around the globe. When storms intersect with these powerful currents, waves amplify and chaos emerges, producing some of the deadliest seas on Earth. The Southern Ocean encircling Antarctica is a prime example of oceanic hostility. Its waters are subject to the full force of the roaring 40s and furious 50s latitudinal wind belts that have no continental obstruction. Waves can build for thousands of kilometers, unimpeded by land, forming colossal swells. Mariners navigating these waters confront cold wind and water temperatures that can rapidly induce hypothermia. Icebergs, submerged or partially visible, add another hazard. Yet these same waters drive global circulation patterns, connecting ocean basins and distributing nutrients that sustain life from plankton to whales. Here, danger and vitality coexist in a delicate balance. Storm formation is intimately linked to sea surface temperature, atmospheric pressure, and the Coriolis effect, the apparent deflection of moving air due to Earth's rotation. When these factors align, cyclonic systems intensify. Modern meteorology uses satellites, radar, and computer models to track storms, predicting paths and intensities with increasing accuracy. Yet even with advanced forecasting, the ocean remains unpredictable. Storms can rapidly intensify, surge unexpectedly, and redirect, reminding us that despite centuries of study, the sea retains a capacity for surprise. Rogue waves and storm surges are not merely hazards for humans, they are natural components of energy redistribution in the ocean. A single rogue wave may concentrate energy from a broad area, transferring momentum to ships, coastlines, or subsea structures. Understanding these phenomena has led to improvements in ship design, offshore platform engineering, and maritime safety protocols. Naval architects study wave height distributions, resonance effects, and structural stress to ensure vessels can withstand forces beyond historical experience. The ocean's unpredictability drives innovation, demanding that humanity adapt or face catastrophic consequences. Beyond immediate physical danger, the ocean's extreme dynamics influence climate. Hurricanes extract latent heat from the tropics and transport it poleward, moderating temperature extremes. Ocean currents redistribute thermal energy, influencing atmospheric circulation patterns that affect rainfall, drought, and storm frequency globally. Upwelling zones where deep nutrient-rich water rises to the surface are vital for marine ecosystems and fisheries. These systems are inherently linked to extreme ocean phenomena, demonstrating that the forces that challenge human survival also sustain life on a planetary scale. The science of waves is itself complex. Deep water waves behave according to the interplay of gravity, water depth, and wind. Wave interference, both constructive and destructive, can amplify individual wave heights, leading to rogue waves. Shallow water amplifies waves further as energy is compressed vertically. Seafloor topography, such as underwater ridges and continental shelves, affects wave propagation, causing focusing, reflection, and the sudden formation of towering breakers near coastlines. Understanding these principles is not abstract, it is essential for navigation, coastal planning, and disaster mitigation. In the modern era, satellite observation has revolutionized the understanding of ocean extremes. Synthetic aperture radar, altimetry, and infrared sensors allow for real-time measurement of wave heights, wind speeds, and surface temperature anomalies. Buoy networks complement satellites, providing localized measurements of currents, wave spectra, and storm surge potential. Data integration through computer models allows researchers to forecast not only hurricanes but also the probability of rogue wave occurrence, informing shipping routes and emergency response. The human dimension of ocean survival adds profound depth to this story. Mariners, researchers, and adventurers confront the full force of storms, relying on skill, experience, and increasingly sophisticated technology. The design of modern ships incorporates lessons learned from centuries of shipwrecks and oceanic disasters. GPS navigation, radar, satellite communication, and reinforced hull structures mitigate but cannot eliminate the inherent risk. Survival in extreme seas is a combination of preparation, knowledge, and respect for forces beyond human control. Historical accounts of oceanic survival reveal extraordinary resilience. From the sailors of the age of exploration to modern research crews, individuals have endured hurricane winds, giant waves, and sub-zero spray. Their experiences provide case studies in human adaptation, leadership under stress, and the psychological challenges of confronting an indifferent and powerful natural world. Each story reinforces the idea that while the ocean can destroy, it also tests ingenuity, courage, and perseverance. Extreme ocean events also provide insight into planetary processes. Understanding storm dynamics informs atmospheric modeling and climate science. Studying rogue waves improves knowledge of fluid mechanics, turbulence, and nonlinear systems. Research into extreme seas parallels studies of planetary oceans, from Europa's subsurface seas to the violent storms of Jupiter and Saturn. In this way, Earth's most dangerous oceans serve as analogs for extraterrestrial exploration. The aesthetic dimension of ocean extremes cannot be ignored. In 4K OOD, every crest, foam spray, and lightning flash is rendered with clarity, transforming scientific observation into immersive experience. Visualizing waves tens of meters high, storms expanding across hundreds of kilometers, and clouds forming in spiraling vortices allows audiences to perceive the scale and power of natural systems. These visuals inspire both awe and humility, emphasizing that human existence is precariously small against planetary forces. Rogue waves, storms, and extreme ocean currents illustrate the concept of nonlinearity in natural systems. Small variations in wind speed, current, or wave phase can create outcomes exponentially larger than anticipated. These phenomena are case studies in chaos theory applied to real-world physics. Understanding them requires integrating fluid dynamics, thermodynamics, meteorology, and observational data. The ocean is a living laboratory, continuously offering extreme examples of complex system behavior. In documentary form, the ocean emerges not as a passive backdrop, but as an active participant. Currents, waves, storms, and tides interact with each other and with the atmosphere to produce outcomes that can be both deadly and life-sustaining. Every extreme wave redistributes energy. Every cyclone transports heat. Every storm surge sculpts coastlines. The ocean's cruelty and productivity are two sides of the same system, revealing the inherent duality of nature, danger and life, destruction and creation. Surviving these conditions depends not only on technology but on respect for natural laws. Navigation requires understanding wind, waves, currents, and weather patterns. Engineering depends on anticipating maximum stress and load. Scientific observation relies on careful measurement and modeling. The ocean challenges humans to adapt, innovate, and continually expand understanding. It is a teacher, ruthless but effective, illustrating principles that extend from local navigation to global climate understanding. From the perspective of planetary health, the ocean's extremes are not anomalies but necessary mechanisms. Storms transfer energy from the equator to the poles. Waves mix nutrients and oxygen, supporting ecosystems. Currents regulate climate by moving heat and influencing atmospheric circulation. Rogue waves and extreme seas remind humanity that even when technology advances, some forces cannot be fully controlled. Respect and understanding are the keys to coexisting with these systems. As the journey continues across Earth's most dangerous waters, the interplay of meteorology, oceanography, and human experience reveals a narrative of challenge and discovery. Monster storms, towering rogue waves, and relentless winds are not merely obstacles. They are windows into the energy flows that sustain the planet. They are laboratories where the laws of physics are made visible, audible, and tangible. They provide context for climate science, disaster preparedness, and understanding the limits of resilience. The ocean's extremes are also reminders of scale. A single storm can dwarf human settlements. A rogue wave can tower over the tallest ship. Currents can traverse entire ocean basins in months. Yet these forces operate according to predictable laws when observed through the lens of science. Studying them transforms fear into knowledge, awe into understanding, and peril into preparation. This balance between danger and comprehension defines the human relationship with the sea. In 4K UHD, the unreal ocean frontiers become accessible not only visually, but conceptually. Observers witness the raw power of nature while simultaneously learning the principles that govern it, from the thermodynamics of storms to the formation of rogue waves. From the shaping of coastlines to the survival strategies of life at sea, the oceans teach both humility and inspiration. Each wave, each gust, each surge is evidence of the planet's dynamic energy. The oceans remind humanity that survival is dependent on knowledge, respect, and adaptability. Those who study them, sail them, or simply observe them gain lessons in physics, resilience, and strategy. Understanding extreme ocean behavior is not merely academic, it is practical, motivational, and profoundly inspiring. The ocean's fury challenges the human spirit to rise to the occasion, to innovate, and to endure. Ultimately, the unreal ocean frontiers are a testament to the interplay of power and life, chaos and order. They are a living classroom, a natural spectacle, and a reminder that Earth's forces are immense, beautiful, and exacting. Surviving and understanding them requires courage, intelligence, and respect. As waves rise and storms sweep, the oceans reveal their secrets to those willing to observe, measure, and learn. In doing so, they inspire awe, motivate inquiry, and reaffirm humanity's capacity to engage with the most extreme forces on the planet.